Hey guys, I'm gonna go ahead and get this started. I know that not everybody's here yet. A lot of you guys didn't know it was gonna be this late, which is okay. I'll keep this one short and pretty focused so that it'll make sense if you watch it when you play it back. But this is the quickest and easiest way for me to load a video. It's easier than recording one and going through and changing all the content, or I don't know, getting it all formatted and uploaded to YouTube. So here's what we're gonna do. This is gonna be kind of new. We're going to be finding the domain of each of these of some functions, right? And so, yeah, well, let me show you how that works. Okay, so you got to remember, of course, I think you guys know the domain is the set of all possible inputs. Those would be the x's, right? And so it almost doesn't make any sense to find the domain of a function for most of the kinds of functions you guys know about. So like if it was linear, y equals mx plus b, the domain's everything except for the case where you have x equals a number, and then the domain would just be that number. Quadratics, domain's everything. And those are really the two kinds of functions you guys know. So we're going to talk about a couple of examples today. One like this, where it's a square root function, and one like this, where it's a rational function, a rational equation. All right. So, hey Leah, how are you? So let's go ahead and dive into this, right? So if we look at f of x equals the square root of x, well, here's the deal. The let me get my let me get Desmos going on here. I don't even know if I can do. I'm not even sure if I know how to do square root of a function or square root function. I'm pretty sure we can figure this out though. Oh yeah, square root of x. So here's what I did. I went ahead and I used Desmos to graph f of x equals the square root of x. And hey, Ruben, how's things going? And as you see, there's nothing over here. You don't have any outputs until x equals 0. Nothing over here, no negatives. And the reason that's true is because the square root of a negative number, it's imaginary, it's not real. So what you're going to be looking for with a square root function is you're going to be looking for what doesn't work. You're going to be looking for what numbers for x would make the radicand a negative. So what would make it less than 0? So like for example, let's say we had this function right here. Let's say it was 5 and the square root of x plus 4. You see that? 5 times the square root of x plus 4. Well, in this case right here, that 5 doesn't even change anything. It doesn't matter. It doesn't affect the output. It multiplies the output by 5, but it doesn't really change anything. So, like, if you were to look at this one, we want to figure out what numbers would make that less than 0. Do you see what I'm talking about? This would be negative. What number for x would make this less than 0? So, x can't be less than 0. Anything less, or less than 4, anything less than 4 isn't going to be in the domain. And so the graph would actually look kind of like this. 1, 2, 3, 4 right there. And it would look like that. Here, let me show you. On our fancy dancy Desmos again. Here, watch. Let me type it in. 5x, let's see, plus 4. How you doing, buddy? If a is like 3, then the amplitude goes up by 3. So here, this 5 makes end, and you're gonna make an inequality. You're gonna make it less than 0, and you're gonna solve. And so here, that's what's not in the domain. So the domain is actually the opposite. The domain is x is greater than or equal to negative 4. You can put anything more than negative 4 in, and you're good to go. Hey, Chris, how you guys doing? So we're starting out with something new today. We're going to try to keep it kind of simple. Definitely going to keep it shorter because we're just going to kind of cover 2 topics. We're going to kind of cover 2 topics and give you guys a few practice problems. I got them all written up by hand right here. Had a crazy day. Had a pretty, I don't know, had some actions. So the idea is with one like this, what you're looking for is you're looking for what values for x would make this a negative. So how about we try one? How about we had f of x equals 2x plus 5. Can you guys figure out what the domain would be? Ale, how you doing today, Ale? I hope all is well. So, and so let's go ahead and let's see if you can get that one figured out right there. Try it on your own. Try it on your own. Let's see. I'll wait for a little bit and see if you guys can get this one figured out. What is the domain of that function right there going to be? And then I also wanted you guys to know, I know you guys are way past this, but changing from standard to vertex form when A isn't 1, I made a video of that today. It's like, kind of a produced video. It's not like one of these. And if you want, I can put that, I'll put the link to that in your Google Classroom. I know that's one of the trickier things. So did you guys get this? Let's see. Check this out. We want to figure out what would make this thing, what values of x would make this a negative, because those won't be in the domain, right? So the values of x that would make this entire radicand negative are not in the domain. The domain will be everything else, right? So what you're going to do is you're going to say this right here. Negative is less than 0. So we're going to solve that, because that's going to be all of the stuff. This will be, if you solve this for x, what you're going to get is you're going to get all values, sorry, it's a sloppy handwriting, you're going to get all the values not in the domain. The domain will be everything else. Do you understand? So what we're actually doing is we're finding the, what we're actually doing right here is we're finding the not domain. That's a slippery concept right there. Hey, Danitza, how's it going? Hope things are well. But this is a slippery concept right here. We're going to find the not domain, and that's going to tell us what the domain is. And I know that's a tricky thing. In fact, I haven't taught this particular topic for a few years, quite a few, 5 or 6. But I do remember that when I used to teach this kind of stuff, that was one of the most confusing ideas, is that in order to find what the domain is, what we actually do is we find what the domain isn't. And we remove that from the set of real numbers. And then we say, oh, here's what's left. And what's left is the domain. So for this one right here, if you solve it, you're going to get x is less than negative 5 over 2. Do you see? So that's these anything less than negative 5 over 2 is not in the domain. So that means everything more. So that means that the domain is going to be everything. Whoa. I'll start over. Now, you know what? I get to use one of my favorite jokes. Now this looks like your picture in the yearbook. Sorry. All right, so that means that the domain is actually going to be everything greater than or equal to this. And here's how we can check to see if this is true, right? We're saying it's everything larger than this. So including this. So I'm going to actually plug that number in. And we're going to see if we get an output that's a real number. So imaginary numbers are square roots of negatives, and those aren't going to be part of our domain. So that reduces to negative 5 plus 5. So that gives you the square root of 0, which is equal to 0. 0 is a real number. That's no problem. That's good. And then, of course, everything larger, like, say, 10. So if you did 2 times 10 plus 5, well, that's 25. Square root of 25 is 5. That works, see? So anything greater than or equal to this would be in the domain. So the domain is all numbers greater than that. There's lots of different kinds of notation styles that we can use to write those answers, but we're just going to do like that for right now. How do you guys feel about this kind right here? If it's rational, or if it's a square root. Do you guys feel pretty good with that? You could just say in the comment box, you could just say, yeah. Hey, Paula, how's your afternoon going? I hope it's going well. I know we had a late start today. It's actually way after school. Who knew? I just wanted to, I want to see, this is our new normal for right now, and I want to keep in a rhythm. And even though it's like after hours and everything, I know you guys are at home with nothing to do, and, well, maybe you have nothing to do, but if you had nothing to do, it doesn't really matter for the time, and so I just wanted to help you guys out. So Ruben's confused. Omar says he thinks he's got it. So, man, let me see. Let me see if I can give you something visual. Danitza's confused too. Okay, all right, no problem. Let's see. I got an idea. Hold on, let me turn on the document camera again. So you know how on a graph you've got an x and you have a y, right? And you know how if you had something like a parabola, we could keep going. We could keep looking this way forever and ever, and the parabola keeps opening up. It keeps getting wider in both directions, and so the domain is all real numbers. The domain is all real numbers. You can plug anything you want in there. So, like, let's say this was f of x equals x squared. I don't know, minus 3x minus 5 or something, right? You can plug any number you want in there, and you always get out a real number, and just one. So you can put any number you want in there, and that's why the domain is all real numbers. And Paulo wants to know, how is my afternoon? My afternoon is quite wonderful. In fact, it's great. Thanks for asking. Okay. That's for a quadratic. And that's why quadratics are always all real numbers. But if we did something like this, f of x, oh wait, I'm going to change page because I'm kind of running out of room there. Let me flip this over. So let's take a look at the one we were just talking about. The square root of 2x plus 5. Okay? And let's do a little bit of let's do a t-chart. Let's do an input and an output table. Do you see? If I can come up with a number that I can plug in and I don't get a real number out, then that's not in the domain. Yesenia wants to know if she is late, and absolutely not, Yesenia. In fact, not in the slightest. Oh, Ale says you're very late, but, you know, this wasn't scheduled on a time this afternoon. Things were a little crazy, and I had the meeting, and I don't know. So, you're not late at all. In fact, I'm late, if anything. So I deserve a tardy. What are you going to do? So here's what we're going to do. We're going to do a t-chart. If I can figure out a number that I can plug into here and I get an answer out, a real answer, then that is in the domain. So like the one we just did, what did we do? We did 10. If I plug a 10 in, right? If you plug 10 in, 2 times 10 is 20, plus 5 is 25, right? And the square root of 25 is 5. See? That's an input, and that's an output that works. Another example would be 0. I can plug 0 in. If I plug 0 in, 2 times 0 is 0, plus 5 is 5. So that's the square root of 5, but that's still a real number. Then you can put that in a number line. You can order it, all that kind of stuff. I could even put in a negative 2 if I wanted, because 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. The square root of 1 is 1. All of these, this is not the entire domain, but they're all in the domain. Do you see? You see what I'm talking about right there? Hey, Vanessa, how's things? I just got an error message that says I might be buffering. I'm gonna give it just a second because I know it's really confusing when things are buffering. So I don't know. I can't tell, but we should be okay in just a second. So I kind of, before I continue, I want to just give this stupid buffering thing just a second to see if my internet speed will pick up. I know it's raining and we have one of those satellite internets, so yeah. The domain is the set of all possible inputs, Yesenia. The domain is a set of all possible inputs. Okay, so we're good now. We're back on track. So the domain is all of the inputs. This, over here, these would be examples of things that are in the range. So this is, domain is X, and range is Y. Yeah, that's right. So, what we're looking for is we're looking for what is actually not in the domain. Do you see? Because you know how numbers go from all real numbers go from negative infinity to positive infinity, we're looking to see if anything's missing. We're looking to see if there's a number I cannot put in here. For example, negative 10. If you put negative 10 in, here's what happens. Watch. You get 2 times negative 10 plus 5, right? So that's negative 20 plus 5. That's the square root of negative 15. That's not a real number. That's imaginary. And so that right here is not real. Do you see what I mean? So for example, that number is not in the domain. Another example of a number that would not be in the domain would be negative 20, right? Because negative 20 times 2 is negative 40. Negative 40 plus 5 is negative 35. And the square root of negative 35, no bueno. Not real again. So it's not in the domain. So these are examples of things that are not in the domain. Those are examples of things that are not in the domain. What do you guys think? Does that kind of make sense? Like, maybe not how to find the domain yet, but do you see why some numbers, some values we can use as inputs and some values we cannot use as inputs? Because if we use those numbers for inputs, we don't get a real number back. Let me know in the chat room. It's the best way for us to communicate. Like, you can just say, yeah, I got that. So here's my question. Ready? Do you understand why some numbers cannot be in the domain and why some numbers can? So yes, no, that's all we're looking for right now, because that'll give me an idea of how to help you guys like move forward. I think there's a 30-second. And it's too late. I'll have to do it next one. Stopwatch. Yeah, I was going to use my stopwatch on my phone and see how it goes. So let me know. Tell me in the chat box if you understand why some numbers are not in the domain. Ruben says he gets it now. Okay. And I'll give it a couple more seconds. See if anybody else says yes or no. Because I don't want to move on from here. Alicia doesn't have a full understanding of it. So you don't understand why some numbers cannot be in the domain? That's my question for you. Omar's got it. Yeah. So some numbers, so Alicia, that's what I think you mean. Some numbers cannot be in the domain because if you use that number as an input, you don't actually get a real number back out. So for example, this is the one we're working with right here. And if I plugged in, okay, I see your question, Alicia. So if I plugged in f of negative 40, you're going to get negative 75 when you do the math, you see? And the square root of negative 75, well, this is asking what number times itself is equal to negative 75. So you're looking for a number squared that equals negative 75. So this is kind of weird. We're actually getting into something that's we're getting into something that has to do with some math you don't know about at all, really, or you don't know about, so you don't really know. Yeah, so Ali, the answer to your question is absolutely. So we'll show you this one on a graph in just a second, Ruben. So check this out. The reason that you can't use negative 40 is because you end up with the square root of negative 75. Square root of negative 75 is asking a question saying, hey, what number squared is 75? Right? What number squared is 75? So here's the problem. If a is positive, a positive times a positive is a positive number. If a is negative, well, a negative times a negative is a positive number. And a doesn't equal negative a. That's not a number squared. That would be two different numbers. So do you see? Like with our real numbers, the numbers you guys are really familiar with right now, you can't answer this question. So that's why if you have a number that's too negative, too small, it's anything less than 2.5, you end up with not a real answer. All right, I got a couple questions here. Let's stop and read, make sure I got all the questions. So last one was Ruben about the graph. We will graph it for sure. Does it only apply to square roots? No, but that's what we're going to start with for now. So Alicia wanted to know, does this only apply to square roots? And the answer to that is no, it applies to other things too. It does not apply, though, at all to cube roots, because a number cubed, a negative cubed is negative, and a positive cubed is positive. So you can do like the cube root of -8 is a -2. Yeah. Okay, Yesenia says, so is domain always infinity to a number? Or vice versa? No, it's not. But what we're going to start with right now that's a really good question. So like the ones we're going to do right now, the domain for these is going to be, for the square roots, is just going to be, like you said, it's going to be like some set of numbers from infinity to here, or just like you said. So from negative infinity to a number, or from some number to negative infinity. Okay, so look, do you guys see when we figure out like what's the smallest value that we could work here? So what we want to do is we want to figure out what value of x would make that negative. Less than 0 is negative, right? That's less than 0, so it's a negative. Because it's less than 0, it's negative. You take the square root of a number, less than 0, it's imaginary. So we solved it, and you're going to get -5/2, right? So anything smaller than that won't work. Anything smaller than that won't work. So that's 2.5. So if you did -3, it wouldn't work. Like, for example, that would give you -6 plus 5, which is -1. And the square root of -1, nope, not a real number. It's a number. It's just a number you don't know about. It's this number right here. Maybe next week, or maybe even tomorrow. Well, maybe we can get into that a little bit. We'll see. Okay, so here's the deal. All of these numbers are not in the domain. Any number less than that, it's going to work out like these right here. You're going to get something that's not real. So all of the numbers that do work are the ones that are bigger than it or equal to. Because you could plug this in, you just get 0. And the square root of 0 is a real number, it's 0. So all of these numbers are in the domain for sure. All right. Oh, why do we use the inequality? So Ruben wants to know why we use this inequality. Because here's why. Less than 0 is negative. Anything less than 0 is negative. So this is all negative numbers, and we're trying to figure out what would make it negative. Does that make sense, Ruben? Yeah, we're trying to figure out what would make it, less than 0. And less than 0 is negative. So how are you guys doing with this? This is the first thing that's new that we've done. And I know it's a little bit of a tricky concept at first, but how are you guys doing with this? Do you think you're doing all right? While you guys think about that question, I'm going to answer Ruben's question about the graph. What would the graph of this look like? And I mean, I can tell you, I can sketch it for you if you want, or I can put it on. Here, I'll just sketch it for you. So check this out. 2x plus 5. So here's what we know. There is, like, if this is 1 and this is 2 and that's 3, this is going to be 2.5 right there. You see? -2.5. And there's nothing over here. Everything is going this way. And it's going to be kind of like half of a sideways parabola. That's the way those look. And so all of everything underneath this curve, all the numbers underneath this curve, those are all in the domain, but this is empty. There's nothing from here that way. All of the numbers in the domain are this way. Yeah. Yeah, you kind of got it. It's kind of iffy. I think you guys have the general idea. And so I just think if you had a little bit of practice with these, then I think you'd be all right. I think you'd get it. All right. I was going to go on to one other example, and that was where the numbers are rational, like 1 divided by something. But, it has a starting point. But I think, I don't know, I'm trying to decide if we should go on to what's next. I think we should just stop right here because it's going to be, with something new, it's easy to get overloaded. With something new, it's easy to get overloaded and confused, right? And so I think we're just going to stop with this one today, and then tomorrow we'll do the other part. So the inverse, Alicia, of x squared is the square root of x, right? And I'll check this out. This is kind of cool. I mean, like, okay, my favorite level of math to teach is the stuff you guys are doing next year, by far. It's like, for me, it's so much fun. So check this out anyway. Check this out. Y equals x squared. It looks kind of like this, right? Well, if you switch the input and the output, and you get the inverse of the function, you're going to get the square root of x. In fact, like check this out. This ties into one of the things we were talking about yesterday. If you want to find the inverse of this, you have to switch the x and the y. And then you solve for the new y, right? Take the square root of both sides. So f inverse of x for this would be the square root of x. You see? The square root of x is actually not a function. Because, like, for example, let's do square root of x right here. Let's say that's our function, y equals the square root of x. If you put in 4, you actually get two answers out. You get 2 and negative 2. If you put in 9, you get 3 and negative 3, because the square root of 9 is 3 and negative 3, do you see? So actually, it would look like this. It would be a sideways parabola. But what we do to keep it a function is what we end up doing is we end up saying it's like this. And we end up saying that y is greater than 0. So we don't actually draw any of this. So that's why if you use a graphing calculator or like Desmos to graph this, it's only going to show you the top half, not the bottom half. But it would actually look kind of like this. Yeah. Like this one would be the square root of x, and this would be x squared. Kind of weird, right? Anyway, at least I think it's weird, but I kind of nerd out. So here's what I want you guys to try. Here's what we're going to do. If you guys just try these, I think you're going to get it. I think you got enough right now where I think you're going to be fine. So I got 4. Now let's do 3 problems. Just do 3 problems. Be cool in the future. Some of it's like, I mean, especially like right now with the coronavirus outbreaks and stuff, it's like really applicable to real life, and it's kind of neat. But not that the coronavirus is neat, but you know, you get me. You got me. All right, so let's try a couple of these. I'll go ahead and write them over here for you, okay? So for today, and we'll go over these in the morning, here's what I want you to do. I want you to find the domain of each function. Okay? So the first one is going to be x minus 5. And the second one's going to be a little trickier. Let's do, let's see. We'll keep it kind of basic. Let's do 2x minus 3. Let's do the third one. Let's do 4 minus 3x. And let's go ahead and do 4. Okay, let's just do 4. Let's say, man, there's one I was thinking about trying with you guys, but I don't really know. So let's do 1/2 x minus 8. So let's try that. And I think it's challenging enough trying to learn something new in this kind of setting, much less trying to really push your understanding in a new context. Or yeah, so let's just see if you guys can figure out how to do these and get them right, and then we'll go over them in the morning, and then also in the morning maybe we'll talk about the next thing, which is the rational functions, finding domains of rationals. So let's see. So we should be good. I know that I've got some buffering stuff going on right now. I don't know why my internet's so bad. It's not really raining that hard. It should be fine. But anyway, let me know how that goes. Give it a shot in the morning. We'll go over these things and call it good. So I hope you guys are doing okay. Just like I was saying earlier this morning, and I think it's worth repeating every single time, this is our new normal. We're going to be okay with this. You just got to be patient. Going to be fine. If you need something, speak up, reach out. It's all right. Be nice to your mom. She's probably ready to kill all of you. Well, like maybe not Ruben's mom ready to kill all of you, but she's probably ready to kill Ruben. Follow me? All right. So I'm excited about dinner. We're having carnitas burritos. Oh, yes. So anyway, hey, you guys have a wonderful afternoon. And yeah, can't wait to see you guys again in face to face in school. Don't know if that's going to happen this year. As of right now, they say April 10th. Who knows? Anyway, I will talk to you guys later. Have a good afternoon.